Hello everyone and welcome back to the workbench where once again we have yet another broken thing. This right here is a 1200 watt inverter from Westward that a friend of mine found. I was getting chucked, and as you can see it's not in the greatest condition. This is pretty much kind of what it looked like when he gave it to me to look at, and here's a few screws that I've actually removed, but it was already missing some screws. The cover screws, or the screws for the sides here, they were already gone. And as we can see here, these are the fans, and actually fairly decent sized fans for this thing, I would say, and they actually look pretty clean. So it's like this thing was barely used. It still looks fairly new and in pretty good condition, save for this label right here that looks like it's kind of peeling off, but I mean, whatever, that's not a big deal. So anyways, let's flip this over. I can pretty much tell you right off the bat that this thing's going to need new MOSFETs, and I'll show you why. Some other little things here. Somebody had added a remote hookup here, a sort of a DIY remote hookup where all they did was connect or solder these two to the switch right here, the power switch, so that basically they would just leave this in the off position, and then they would have another switch over here on this side somewhere, and then that's how they could turn it on and off remotely. So if we flip this over, the cover was actually missing previously, but my friend was able to get it. Here on the cover is a little USB connector, so that you could use that to like charge a phone or something when you have this thing hooked up. So there's the power input, and we're going to be testing this because the bottom looks pretty crusty, and I'll show it to you guys in a little bit better here in a minute. So set this aside for now. But here is the main board on the bottom. I had already removed the screws that hold this down to the casing here. There was 4 screws holding it down. There was a couple more screws here on this on the bottom of the heatsink here, and then there's another heatsink up here. So the MOSFETs that drive the power transformers in there are the ones on this side are definitely shorted, and I'll get you in here a little closer in a minute. The ones on this side possibly kind of questionable, but we're going to be replacing these for sure. There's 4 down here, and there's another 4 up here. We're going to be replacing these for sure, and we're just going to take care of these while we're at it. But what we also need to check is make sure that the drivers for the gates, make sure that those are operating properly, or make sure that the Pwm controller down here is operating properly. Just in case, make sure that something there hasn't shorted and has caused one of these outputs to, like latch high or whatever, and basically just keeping the MOSFETs on high the whole time. The way this works down here, there's actually 2 boards inside this inverter. There's this board, and then there's another board that you can see down there on the bottom. So this bottom board generates the high voltage and steps up the 12 volts up to, I don't know, it's like 100, I think it's a little over 120. This is a 120, well, it says 115 volt, 60 hertz output for the outlets there, but I think it steps it up to slightly above 115. So what it does is that 115 AC gets rectified down here. There's a couple diode bridges down here, or it's a couple of dual diodes. So that gets rectified. There's a cap here that will that power goes to the other board, and then the other board takes care of generating the 60 hertz AC. So there's 2 sets of MOSFETs here. Each set drives 1 transformer, and same thing on this side. So all 4 of these transformers are kind of like operating in parallel, but then their outputs are all connected in series. So each transformer would say do like 1/4 of the total output voltage. But the ones down here, as we can see, have taken quite a bit of damage, and somebody had already apparently tried repairing this, but it doesn't look like they bothered replacing the MOSFETs. So what happened is these fuses blew. Not the ones on this side though, just the ones on that side. So this side is obviously the one that took the majority of the damage there. So we're going to have to remove those heat sinks, remove the MOSFETs, and figure out, what they are. Alright, so now if we get a little bit closer here, we can see that somebody took some wire and basically kind of made it like into a jumper to come all the way down here into the drain of these MOSFETs. So basically we have our gate, we have our drain, and we have our source. And our source down here is this big track. That's the one that's going straight to the negative input terminal. and then that's the drain going out to drive one of the coils on the transformer. And we can also see that these resistors right here are pretty blown. So that one there was supposed to be a resistor, but now it just looks like the substrate material, like kind of charred and black there. And then there's another resistor on the bottom. So this resistor on the bottom here, this 472 I believe, so that would be a 4.7K resistor there. That's looks like it's going to the gate, so that would be kind of like the pull down, so that in case something happens over here, this doesn't latch high. And here's the other resistor, that one also there, you can see it got blown. So basically that would be the gate resistor, the ones that are blown up here. And yeah, that's our pull down there. So yeah, pretty much all of them look pretty bad. Well, the pull downs look fine on these gates here, but these other resistors look pretty terrible. So down here on this section of the board, we have our gate drivers. So there's 4 transistors right here on this this little section here. We'll see them on the other side. But then this here is going to be our Pwm controller. So this controller turns like, switching these transistors, and there's basically only 2 sets that go out. So one set here drives 4 MOSFETs to pull the transformers, to swing to one side. And then when that one shuts off, then the other one turns on, and then that pulls the transformer in the other way. That way, it oscillates back and forth to generate our high voltage on the outputs of each one of those transformers. So we're going to have to check these 2 right here. After we remove all these MOSFETs, of course, we're going to hook up the scope, and we're going to make sure that we're getting some sort of PWM signal on these two pins right here, basically. So we're going to hook up two probes to the scope and make sure that we're getting those square wave oscillator, going back and forth. If not, then that means that something happened to these drivers down here, and we're going to have to possibly replace those, assuming that nothing's gone wrong with the controller down here. Some other things of note down here is it looks like right here there was supposed to be some resistor. I don't know if this was also part of whoever did this here, or if this was from factory. See, right here it looks like there was supposed to be a surface mount resistor, but this got connected between here and here. So I don't know if that's correct or not, if something else got changed in the original design or whatever. So that's a little questionable, but it does look like a few other things have gone on around here. Some of these looks like they've been scraped or something, or maybe something was there. Somebody's looks like they've had a crack at this. So we're possibly going to have to do a little bit of poking down here and see what's going on. But the good thing is that these inverters are pretty basic in the way they function. It's just like a PWM controller, controlling the high voltage here. Some of this stuff here I think this right here might actually be an op amp or a comparator or something, just to make sure that the voltage output stays within like a spec or whatever. And yeah, but other than that, that's basically all this does. It's just make sure that the output voltage stays at a certain level, while the output section, the circuit down here on the bottom, is the one that takes care of doing the 60 hertz oscillations. Alright, so this board here on the bottom, there's also another couple MOSFETs up here, and then there's a couple more here on the bottom. So this board is a little bit, there's really not a ton of stuff going to it. Like we see this here's one of the outputs, and then this yellow one's the ground, and then there's a blue one down here, which is the other AC output. The only other connections going to it are these two, which are the high voltage lines, and then this other little connector here that's for like the low voltage stuff to power the board up here on top. So I don't think we're going to see any problems on this board up here. Pretty much everything's going to be concentrated on this board here. So let's remove all this stuff, and we'll see what sort of MOSFETs we have, and make sure that we've got the proper PWM signals down here on these pins. Part of the problem appears to be that it looks like water actually got into the bottom of this inverter. As you can see there's evidence of some sort of liquid spillage. And if we look at the bottom side of that USB board, you can see that there's a bit of corrosion going on there. So I don't know if anything got damaged here. I mean, the only thing that would really have gotten damaged is probably this IC right there. If that is damaged, that'd probably be pretty easy to replace. It might just need a cleaning. It's I mean, all it does is take like 12 volts and then it steps it down to 5. So I mean, and even if it is damaged, I don't think my friend's gonna really care that much if I don't fix it, because I mean, we don't have like other charges. You know, why do you want to use the USB on the inverter unless it just happened to be like super convenient to, you know, have it around? Other than that, yeah, I'm not sure. But anyways, we'll see if we can get it working. If not, like I said, it's probably not going to be a big deal. Okay, to make things easier on us here, we're going to have to remove this board from the bottom casing. The problem is that it's kind of mounted in these grooves. So, well, actually, if I stretched it out enough, it came out. But anyways, what I'm going to do is I'm going to desolder these the high voltage connections going out to the bottom board, just so we're not tethered to the bottom board here. And plus, we might want to check the voltage output there anyway, so that's easy enough to do. We just have to melt these contacts here, or these solder joints, and this will come right out. So these are our high volts going out to the bottom board. Now our top board can easily come out, and we can set it down like so. What else do we have here? We've got the connection going out to that USB board there. We got this connection going up to the top board. We have some stuff here that looks like it should be able to come off. Yeah, here's another connector, but there's a zip tie here kind of stopping us. So let's just snip that off. Okay, now this connector here should just come out. That connector there is for the switch, but they do have these little clips on these connectors so they don't easily come, or so that they don't come off too easily. Okay, so that came off. What else do we have? We have another 3-wire set here that goes off to the indicator LED up here in the front, but we should just be able to pop this LED out and pull that to the side. Alright, now we have got our main step-up board isolated, so we should be able to do some work on this now. Alright, so here's our Pwm controller. That is a KA3525. So that's the one that's driving these transistors here, which are our gate drivers, which we're going to have to check and make sure are okay. All these big wires here are just for distributing power around the board. As we can see, this is our negative terminal, and instead of running like big beefy traces, like, you know, all through the board from like one side to the other, they just basically jumped from there over to here. And same thing with the positive. They actually strapped a cable here from the terminal right to the bottom there where the fuse inputs are, even though they do have some like really beefy tracing or traces going on right there. Here's a screw. We'll pull that off just so we don't lose it, and here's another one. Pull that off so we don't lose it. So yeah, even though they've got this big trace going on right there, they also have a little wire kind of strapping that down. And we're gonna have to also desolder these fuses here. The ones on this side are fine, so no worries there, but this one is blown. And funny thing about these things is that the fuses usually only ever blow after some catastrophic failure has already happened. Like, I'm pretty sure that these probably blew first and these were untouched, and then somebody went and put this on there, and then these probably blew. So they didn't blow until, like, you know, somebody else tried to repair it. So pulling these MOSFETs out should be easy enough. We're just going to heat up the joints here and then suck the solder right out. Trying to remove these wires here. They're pretty thick, and we're going to come up with something else instead of these really thick wires that they used. I'm having to melt it as I pull up on it. So there we go, one of those is gone. It was kind of interfering here with letting me suck the solder off of that pin. And I'm still kind of having a hard time pulling the solder out of these just because there's so much solder on each one. And the holes are like really small. So now I got to pull this other one too. Okay, we've got our MOSFETs out along with our heat sinks here. And as we can see here on this side, this is the one that had those, the side that looked like it had been previously, somebody had fixed. As we can see, these MOSFETs between a collector and the emitter are completely shorted. All of these are showing below 1 ohm. It's funny though, because the fourth one here, that one is not shorted between the collector and the emitter, but the base and the collector are certainly shorted. And I believe that's the case with the rest of them as well. Yeah, they're all just completely shot here. So all those are going to have to go, but I still got to see what MOSFETs they are. And on the other side, the one that had the 6 devices, which wasn't obvious from the bottom, but once we removed it, we can see that the one right here, the second one in from the left here, is completely blown. The leg got blown off. The other ones look fine. These two over here are actually the diodes, so I already checked those. There's really nothing going on with those. Those are fine. Just the MOSFETs are bad. I don't know if all the MOSFETs are bad. That's bad. Obviously, that one's bad. This one here is not measuring shorted between any of the... Wait, is it? Can't tell what I'm measuring there. Huh. It's weird. For some reason, sometimes when I touch it, I get something, but not all the time. So that's kind of odd. So that one here, not really measuring shorted, but like I said, we're just going to replace them all anyway. As far as the board's concerned, we can see that where that one that completely got blown apart was, down there, that's all charged. There's a couple more resistors down there. We're going to have to look at those also, or maybe just replace them just completely anyway. And then on the other side, there was a couple more resistors that got burnt up, so those are obviously going to have to go. So here's the 8 MOSFETs that we're going to have to replace. These are numbered JCS3205CH. And the logo for these I didn't recognize right off the bat, because I don't think I've ever seen it. But once I typed that into Google, it came up. The first one that came up was for datasheetpdf.com, and the link here that comes up, it says for Gillensino Microelectronics. So I clicked on the PDF to see the specs of this MOSFET, and of course searching for this MOSFET like on DigiKey doesn't come up, because apparently it appears that this might be like this company's version of an IRF 3205. Because the specs look suspiciously similar, so since obviously we're not going to be able to find these exact ones probably for purchase anywhere, because it's probably something that they sell for these like companies to manufacture these things with, we're just going to go with the RF 3205s, and those are rated at 55 volts and 110 amps for 8 milliohm MOSFETs. So I'm going to have to get a hold of some of those, because I'm not sure if I have any here. But I'll search. I'll see if I have any. If not, I'm going to have to order some. But, yep, that's what we're looking at. So, all these got to go. Out of all 8 MOSFETs that were inside of this inverter, these two are the only two that are actually testing completely fine. So, I wouldn't trust to put them back in anyways. But we're going to do a little experiment here just so I can show you something of why these were testing kind of inconsistently. The rest of them they're completely bad. They're shorted no matter what I do. So yeah, those are completely gonski. But I'm going to take one of these away here, and I'll just show you guys what's basically going on. Alright, so I had my meter set to measure ohms, and I was doing that because I was checking around the board for various different resistors, and also to make sure that there weren't any shorts. And that's how I found out that a lot of these MOSFETs were shorted. Well, when we're in ohms mode, there's a tiny voltage like present at the 2 leads here. So on a MOSFET, we have our gate, our drain, and our source. And the gate basically takes a positive charge and then allows current to flow between the drain, or the source and the drain. So when there's no charge on that gate, say I'm gonna completely just short all these out here, there's no basically there's like super high resistance between the source and the drain, so we get nothing. But if I leave my negative on the source here and I touch the gate with the positive, I'm introducing a tiny charge onto that gate. So when I go back to check for continuity between the source and the drain, it's showing me like a very low resistance, and right there it's climbing because it's basically the the gate is discharging because I'm touching it to the mat here. But if I wasn't, and I do that again, I'll touch the source to the negative, and I'll touch the positive to the gate here, and then I go back to touch the drain with the positive. It actually holds charge for a lot longer. So I get a short between the drain and the source. But if I short these out again, and I do that again, see, now we're getting nothing. So these MOSFETs test fine, but yeah, like I said, I wouldn't trust them anymore. Rick from All American 5 Radio channel, he did a really good video on experimenting with that, so I'll link it down below if anybody's interested in knowing a little bit more about that. Like I said, this was just like a quick, just to show you why we were getting inconsistent tests with those MOSFETs there, but basically that's why. So now about these resistors that I mentioned here, these little SMDs that were mounted up here on the top, the ones that have the top blown off. Obviously we can't read those to see what they were supposed to be, and there's one here, and then there was a couple more over on this side here, the one right here and the one right there. But I mean, all those, I measure them and they all measure something different, so those are not going to do us any good at all. But what they did is that while they had a couple of the surface mount ones here for, like, say that MOSFET and that MOSFET, and then the other two MOSFETs up here, for the ones that were a little bit farther down on the board, that's where they used the through-hole ones, like the ones here. But obviously this one here is burnt, and this one here is measuring some other value, so those do us no good. But on the other side, the two here are still intact. So I was able to measure those, and this one here's got some black stuff on it, so it's kind of, but I mean the other one here we can read, but they're 15 ohms. So that gives us our answer there that we need. So basically all those gate resistors need to be 15 ohms. But now that we've got the board in this state with no more shorts or anything, I'm hoping that we can just apply 12 volts at the terminals here, power it up, and hopefully we can hook up the scope and see if we are getting our PWM signals to the MOSFETs here. There's another set of wires that you can see right here that comes off of this area, snakes off into this direction and goes over here. These are the two gate drivers for the signals that drive the gates over on this side of the board. So instead of having some traces going from here all the way across to here, they've just got these two wires doing the driving on this side. We're just about ready here to test the board and make sure that we're getting a proper PWM signal at these pins over here. One other thing we have to do is the fuses that were blown were the ones that were in this section here. And we need to have some sort of a fuse or a jumper or something in that spot, because that's where power comes in and feeds the rest of the control circuitry over here. So there needs to be something there. This one here doesn't matter so much because it just goes to the transformers. But I am not going to directly solder fuses back onto these spots here. What I'm going to do instead, for ease of changing out fuses in the future, or service or whatever, is I'm going to install these terminals, and these are basically just these terminals here that I've taken and opened up the bottom on with a plier, because normally they're like this. They're the type where the wire comes in from the side and then it gets crimped, and then you can use it for whatever you need it for. But these are just the right size, and so what I'm going to do is that I'm going to install one in one direction, and then I'm going to take the other one and I'm going to flip it around, and if I can keep a hold of it so I'm going to flip the other one around like this. That way there is, like, no stress, like only on one side of these, and it should be a little bit more stable. So once they're on the board there, it can't it won't have a tendency to want to lean to one side or the other. It'll just be kind of neutral there. So one other thing I noticed that I had not caught before is that the resistor, it's like a little snubber circuit there. There's a resistor and a disc capacitor down there. You can see them. Those are burned on this transformer. So definitely took some abuse there. The rest of them are okay, but replacing that shouldn't be a big deal. It doesn't look like the transformers actually suffered any sort of damage or anything, so I think that should be fine. I've just kind of tucked the LED in here in the middle here so we can get some status when we power this thing up. So yeah, I'm just going to install those those blade connectors there, and it should be fairly okay to test right after that, so as long as we have a fuse on this side. Alright, I've got the terminals soldered in place, and right now I only put a 2 amp fuse in here because I really doubt it's going to be pulling much current anyways, because we're not doing any actual switching or anything. It's basically all that's going to happen is it's going to power the control circuitry over here, and we just want to make sure that we're getting the PWM signals out. One little tip when soldering these: make sure that you either like sand them or like scrape them or somehow like remove some of the material from like the surface, because otherwise they become a real pain to solder. I had a real trouble trying to get these to stick over here. I mean, I finally did, but the ones over here I scraped first before I soldered them on, and then it was much easier. These here were a pain because I didn't do that. So we are getting ready to apply power here. Clips here. We're going to hook up negative here and positive. Let's turn our power supply on. Nothing should happen. I do have the other board plugged in up here, even though from actually looking at it a little bit closer, it looks like these are just going to the optos that are up here, so it's probably not going to do anything at all. I'm not sure. I haven't completely traced it out to see if it's providing any power through here. It seems like it gets most of its power from the high voltage lines that came out from up here, and then that's where the other board gets fed and everything, and these are just sort of like feedback. So I'm expecting this to light up red or something. It indicates some sort of fault, and maybe even the little buzzer that's down here to beep or do something. So let's see. We are going to turn it on, and yeah, not much of anything is happening. This LED, oh, that's right. I forgot about the power switch. So yeah, we're gonna have to hook that up too. Okay, so I've connected the power switch up here. Right now it's in the off position. So let's turn it on and see what happens. Hopefully the fuse doesn't blow because of like inrush or something, even though I don't think it should, because I think it charges up these caps before that. So let's turn it on. And that's funny. I was expecting like red or something, but the LED is actually green because this is a bicolor LED. So I guess the other board, basically, since there's no power to this, it's not telling this that there's like an overcurrent condition or anything, so it has no idea what's going on. But at least it's powered up. So now let's poke the connector over here and see what we're getting with our scope. Alright, so I've grounded both of these probes from the scope right here on this this diode here, because conveniently enough, that is the negative right there coming into the... It's supposed to be a reverse protection diode, but that's going to do crap with as much current as going to be flowing through this thing. That's, yeah, it's mostly for show, apparently. It's not going to do anything helpful. Alright, so got my two probes hooked up here. Okay, so we have our volts here set to 5 volts per division on both probes. And we've got our time base here at 10 microseconds, and we can see that we are getting alternating waveforms there. So the PWM section is working. So it looks like we should be fine to just put in our new MOSFETs, and this should work. I've already checked the other board just to make sure that there's no shorts, and it doesn't appear to be any. The MOSFETs all check out. They seem to check out fine, so I doubt we're going to have any issues there. Like I said, I'm pretty sure that it looks like water got into this at some point, and maybe that's what screwed up the board. Aha, so I found out that undervolt at the input makes it beep. So check it out. If I disconnect the positive, then it turns red and it starts beeping. So that's I guess that's the alarm. That's the only thing that it's for, is for an undervolt at the input. I decided to pull the high voltage board that was up in the top here from the casing, and I found that there's evidence of like water having been around here. As you can see, there's some stuff right there. If I pull this over to the side here, you can see some right there as well. And I also found that there was a little bit of corrosion right here, right underneath one of those MOSFETs. It doesn't look like it did anything to it, because it doesn't seem to test bad or anything, just from testing it on the board there. So I think that was just if it was operated, or it could have happened that there was a little bit of water pooled up there and it just kind of started corroding away at the material there. And or it also could have had something to do with the the failure on the other board. But I think it's going to be okay. I'm just going to give all this a really good cleaning, and I think it should be fine. So we're going to get ready to test here soon. I already reinstalled all the components on the other board. The boards are back in, so partially. This one's not attached yet. But a few things I did here, I put some heat shrink. I actually redid these connections here to the switch. I put some heat shrink on them to protect them because they were just kind of like out in the open. And right now I've left the two high voltage connections going down to the bottom board disconnected from the top board here. Beefed up the traces going from the high voltage output to the rectifiers and to the points where these two wires are going to solder to. We don't want to have too many losses here because this is like the high voltage section, so we want to get as much power as possible from here to the outlets. And honestly, the traces out here looked a little anemic, so what I did is I took some used copper braid, like this stuff here, and then I just kind of cut them to size, and I embedded them in there with a lot of solder. So these are really chunky now, so there should be like very little resistance, you know, between all these points here. Here I took some just regular stranded wire, and I just kind of shaped it so that would have fit that area, and then I just covered it all in solder. So those are nice and beefy now, and there shouldn't be too many like losses there. For the MOSFETs here, the ones that had the traces like pretty much blown off all the way to where the drain pin is supposed to be, what I did is I also took some of this used copper braid, and I cut the end to be slightly triangular so that I could fit it underneath the drain pin, and then I bent the drain pin down. Actually, I did I bent the drain pin down on all of them just to provide like more material for, like transferring current between all this stuff, because this is like really high current stuff around here. So that way I sort of had, kind of like a trace going from the rest of this here. This is going off to the transformer, to one of the windings on the transformer, to the drain pin there. So those two there were the ones that were like in really bad shape. So it didn't turn out too bad. And I made sure that nothing else here was shorting, so that's gonna work out pretty well. Also, in some of these spots where the surface mount resistors were going to the gates on the MOSFETs, the traces were burnt for where the resistors had burnt off. There was only two of them that were still like in okay shape, but I had the 15 ohm like 1/8 watt resistors already, and there was no point in ordering some SMD resistors just for two spots, because there was only two spots that were like usable. The rest of them, the traces burned off. So instead what I did is I just kind of did like a point to point sort of bodge thing here with the 1/8 watt resistors. And if I could get that to focus, that would be nice. There we go. So it's just sort of like a point to point bodge thing, and these weigh so little. I mean, they practically weigh nothing, that I'm not worried about like vibration breaking them off or anything. And I just made sure that any of the solder points, like weren't going to be too close to touching anything else. So those are here, and then there's the other two right here. So I already checked everything. I have 15 ohms going from, what, like say the point here to the two spots, or actually the four spots that line drives, and then from the other line. So nothing is shorted. Everything seems like it should be fine. I haven't found any issues as of yet. So now that I've got this pretty much hooked up here, ready to go, I've got two 35 amp fuses. One in each of the sides here right now. I don't have all four yet, but we're going to test this, make sure that we're getting a high voltage output here, and if that's working, which it should be, because as we saw, we were getting the switching going on here for the, and that's going to be like driving the transformers back and forth. We should get a high voltage here. There is a feedback circuit here that goes through a optocoupler, to as feedback for the rest here, and nothing else over here looked bad, so it should be fine. So let's do that now. We're going to get the multimeter here side by side. Let's turn up the brightness. Okay, I'm going to turn the power supply on, but I'm not going to, I don't have the switch on just yet. So now, turn this lamp away a little bit, maybe it'll get the multimeter from flickering so much. There we go. Okay, so this is the negative point here, and this is the positive here. Right now we're getting nothing because obviously it's not powered up yet. I'm going to try to get these here in a good spot where I'm not going to be touching it, or the probes aren't going to slide off. There we go. Okay, so let's power it up, and there it goes. So 175, 176 volts is the output going up to the top board. And well, I mean, I keep calling it the bottom board, but technically that's like the top board, and that's like, well, we'll call it the output board. That is the output board. So yeah, about 175 volts going to that output board. So this bottom board is doing just fine. So as you can see, there are some pretty high voltages present here inside of a inverter like this. So if you are working on one, you do need to be careful, because it does, the 12 volts does get stepped up to quite a bit, and it's got quite a bit of kick to it. It's quite a bit of amperage, and this is a pretty relatively high power inverter. It's not like huge, but it does have some power to it. So now I resoldered the negative and the positive going to the output board. I am going to check the voltage at one of the outlets here, and it should be somewhere between like 110, 120. It says 115 printed on the outside of it, but we're going to check and see what it actually is. So I've got the meter set to AC. I'm going to put the power switch back in the on position, and hopefully nothing goes up in smoke on the bottom there. Here we go. So far so good. Okay, so I'm going to go in like the side here. I'm going to put one here. The other one, oh, I guess that doesn't work because I'm blocking the meter. So I'm just going to go from the side here, and I'm going to be very careful not to touch anything. So 108. So, well, a little lower than I expected, but I mean, it's AC, and well, it technically it's a modified sine wave on these inverters. It's not true AC or like a sine wave. So, but that should work. It should power stuff. We're going to test it with some loads here in a bit after I get it all put back together. So at least it's looking good right now. So let's turn it off. We'll finish putting the rest of the screws back together. We'll close it up, and we'll give it a good test. Actually, one more thing we need to check is the little USB outlet here. I actually dunked it in an ultrasonic bath, and it actually came out really clean. Like, it got rid of all that corrosion and tarnish on there. So I think I mean, I don't see any reason why it wouldn't work, unless, like I said, like this chip like got messed up or anything, but it doesn't look blown or anything. So let's check that now real quick and see what we're getting. Alright, so let's see if this little USB board 5-volt outlet is working. I've got it hooked up to the rest of the inverter here. I mean, it's not that it needs the inverter, it's just that it already had the connection there, so it just makes it easy to test. So I've got the meter set to DC again. Let's put the power switch in the on position, because the 12 volt from this comes from the switch. So let's see, hook it up here and here, and 5 volts pretty much spot on. So yeah, this should be working. One other little thing here, there's another set of contacts here or pads for like a jack of sorts, and it says remote. So that was supposed to be for like a remote controller for this unit to probably like power it on remotely and stuff. Obviously it's not populated there, and there's nothing on the board where this will connect to. So, and there's like no opening here for it. So yeah, maybe this is just like a different model or something as well. So yeah, thought that was just funny though. Remote. As I'm making sure that the the case goes on here, one thing that I'm not too sure about is these big terminals here for the power input. I don't know if they were supposed to have some sort of an insulator around here that has gotten lost or whatever. They weren't there when I was given this to to repair, and this one's missing too. There's two like square cutouts here on the plate with the fans, and when you put this on, I mean, they do clear, like they will clear those contacts, but it's not really, doesn't really instill a lot of confidence there. So what I'm going to do is, I do have some pretty big heat shrink here. So I'm going to do, like I'm going to cut a piece out so that it, kind of goes out to like here, just enough for, it'll sort of like protect against stuff like, in there, like something getting jammed in there, making contact between this case and the terminal itself. So I'll cut out one piece, I'll heat shrink it on, and then I'll cut out another one and I'll heat shrink it on top of that. That way it'll provide like a double layer of insulation there on both of these terminals. Alright, see, there we go. So it's not much, but it's much better. You can see that here, like, we pretty much only have like the gap of 2 of these layers of heat shrink there. So yeah, it really wasn't much of a gap between those two there. So, well, at least now I can sleep at night knowing that that won't be an issue. Alright, the inverter's all put back together now, and I dug through my little box of like just random screws there to find some that would fit the case here on the outside, because as we saw at the beginning, all those were missing, so there was like no way to put these side covers on. But now they're all on. I've got some I think this is 8 or maybe 10 gauge cable here going down to my power supply. It's not what you would want to use, you know, under normal circumstances probably, and I also didn't have any like little screws with nuts or whatever so I could put some ring terminals on this to bolt it down. So I just kind of stuck the wire in there and just put a screw there to put some pressure on it, just so it's get some pretty good contact. It's probably not going to matter in this case because my power supply can only handle up to 35 amps anyways, so I'm probably going to overload the power supply before anything happens here. And also at the moment I only have a 35 amp and a 30 amp fuse on each side. So yeah, we're not going to overload this to the point where we're going to blow anything anyways. So we're going to give it a load test now. First of all, let's see. Let's plug in a Dremel here. So plug it in. Let's turn this on. When you first turn this on, it starts. It runs the fans for a little bit. And actually, let me show you here also. There's our little indicator LED. If I turn this off and I turn it back on, you'll see it flashing. Red, green, red, green. Funny thing is that I didn't see a microcontroller at all inside of this thing, unless that very top one on the output board was one, but I didn't check the numbers on that, although I don't think it was. But yeah, so interesting. That flashes, this runs for a few seconds, and it's done. So it's probably all being done with that like little op amp chip, or I don't remember if it was an op amp or not, or if it was a converter. Anyways, so okay, so it's working. Got this on. Let's turn it on. So, running. So yeah, that works. Let's plug in this lamp that I have running this thing, or lighting up the bench here. Plug that in. It's on. Let's run this too at the same time. So it's working pretty well so far. All right, I brought in the drill here, so let's run the drill and the Dremel at the same time, and the lights. It should be fine. And with all that stuff running, I just looked at the ammeter at the bottom. It's drawing about close to 30 amps there. It was just slightly under, but yeah, it was close to 30 amps. So it seems like it's holding up pretty well. The fans aren't even running yet because they're basically temperature controlled. So yeah, there we go. I'd say that was pretty successful. We got this thing working, and give it back to my friend, and he can do whatever he wants with it. So thanks once again for watching. If you like this kind of stuff, remember to subscribe and maybe hit that little bell button so you can be alerted when I upload something new here. I'll see you guys at our other bench. 1200 watt power inverter, let's go. Where are we going?
Westward, bro.